What you see here is the recording of the detention pond, and I'm sorry that it shakes, but that's just something that you have to put up with my recording. Here is the energy center. It gets better. So the energy center has a roof that drains into this pond. A detention pond. You'll see a culvert there on the west side. There's a culvert on the north side here. And then as you can see, the detention pond slopes down towards the bottom. Now there's a bunch of water in the bottom of it there that is from a recent storm. So this is the math part of the detention pond activity. Here is the map or site plan for the Energy Education Center, the outdoor part. And in the upper right hand corner you can see the scale in feet, where 1 inch is 30 feet. What you see here that we're going to be doing is the building here, which we know to be 54,000 square feet. Let's see if I've got that picture. And then the detention pond that we're going to be measuring is in the upper, kind of towards the upper left quadrant of that site. And so you can see from these pictures what the site looks like from each different direction. So now I'm going to orient you with the background. If you notice, they show the road over here, US 12, and that's at 905 feet. You got the ditch down to 895. Then the campus road, which is up here at 890. So, and then the road gradually drops off. The light gray lines are the original elevation, and so you notice 890 here, 889. So this is a little bit lower than that was originally. And then you can see over here towards this side, it's climbs back up to 893. And then this is the original elevations out to the west, 887. So you can see on the other side of the road there that it was a little bit deeper. Okay, but here is the detention pond that they built. Let's start at the top. It says the water level at the top is 888.45, and if you notice, they quit making the detention pond here at the 889 level, because by then the water would be contained by this bank that goes up to the road grade. There's a pipe coming in on the left hand, or on the south side, and there's also one on the north side, which I'm northeast side. I'm not sure what the purpose of that one is. You can kind of see it pictured here. I guess I don't know what the purpose of that one is. And then as you go down from 889, I think we're going to start our measurements at the 888 foot contour. And then you go down 885, or I'm sorry, 887, 886, 885 is the dark line here, 884, and then the bottom of the pond is at 883.5. So what we're going to do is to make a frustum pyramid of this area, and I'm going to show you how we're going to make that construction. Each of you has been given a piece of paper, and what you're going to do is to construct a triangle, well, not construct, draw a triangle inside that area that will be the bottom of the drainage area and the top of the drainage area. So the first line that I'm going to draw here, I'm going to draw the bottom of the triangle, of the frustum in red, and then I'll draw the top in blue. So you kind of have to guess for these lines, which makes it so that when we do the actual calculation, we're going to be pretty, I think we're going to be down to 2 sig digs on our measurements, which is okay because the, excuse me, the area of the floor area of the building is only given to 2 sig digs, 54,000 square feet. Okay, so then the bottom of the triangle, and if you notice that's a curved side, so it's a little bit difficult to measure that. And then this side of the triangle. And then we're going to measure those 3 sides. Now when I did my drawing, here's the measurements that I got. I got, let's see, 135 feet here. I got 98 feet here, and I got 105 feet here. And then I did the altitude for the triangle. I did over on this side, and I got that altitude to be 75 feet. So then for the big triangle, I'm going to do that one in blue just so that you can see how I did that one. This will be at the 888 contour. Okay, there's that side. 888 contour, you kind of have to cheat on that one a little bit too. Let's see here. And then over here on the left side, 888, you get like this. Okay, and for that triangle, I got this side is 210 feet. This side was 150 feet, and this side was 165 feet. The other thing that you'll notice is those triangles are actually pretty close to being similar triangles. So I was thinking this was going to be a weirdly shaped pyramid, but it actually is pretty close to a triangular shaped pyramid. The other thing to remember is we were doing the 888 contour and the 883 contour, and the difference between those two was 5 feet. So remember that our frustum has a height of 5 feet. Then when I did the this triangle's altitude right here, I got that height to be, well, I have to do the math because I didn't multiply it out. It was, oops, I'm going to make this smaller. It was 3 3/8 inches. And then you have to multiply that by 30 feet per inch, and you get 101 feet. So this is 101 feet. Okay, now I think those are all the measurements that we need to complete our calculations. So I'm gonna now I'm ready to do the calculations. So the volume of a, I'm going to X that out. The volume of a frustum is, this is in your textbook on page 198, it's equation 97. The frustum of a pyramid is the height divided by 3 times the area of the first base plus the area of the second base plus the square root of the product of those two bases. And so what we need to do first of all is to find the areas of the bases. We know that that first triangle, that's the bottom triangle, is 135 feet by 75 feet. And then remember, the area of a triangle is 1/2 base times height. So let's do that calculation. 135 times 75, and then divide that by 2, and we get 5,062.5. The second part of the pyramid, which actually is going to be upside down because that one's going to be a bigger area. It's 210 feet by 101 feet. Remember, that was the one that we just calculated. Divide that by 2. So we have 2010 by 101 divided by 2, and we get 10,605. And now I think we can do our calculation. So our volume will be the height, which we said was 5 feet, times the two areas added plus the square root of the product of those areas. Okay, so when we do that calculation on our calculator, it's fraction 5/3 times the product, the product of the sum of 5062.5 plus 10,605 plus the square root of 5062.5 times 106.05, and then close the parentheses, and we get 38,324 cubic feet. So if you figured that out, you would say, well, the roof has an area of 54,000 38,324 cubic feet. And then if we take that and see, well, how many feet of water can fall on the roof and that detention pond be able to hold it, and we find out it's about 0.709 feet. Is convert that into inches. So what we would do is multiply that by 12, and we get about 8.5 inches of rain can be held in that pond. Now the other thing that's true is that once that rain falls in that pond, we can find out how much the soil can absorb, and we find that the soil can absorb about 6 inches of rain per hour, between 6 and 20, which is a big margin. So the rain can fall pretty steadily, and that detention pond should be able to hold it.